So here I have some books with me, in fact a lot of books with me, and I would like to fit these books in this cupboard here. So here I have a cupboard below the table, and I would like to fit all these books in that table, in this cupboard below my table. But I have a small doubt. Will all these books fit inside this small cupboard that I have? So how do I find out that thing? So one way is obviously to try and fit them inside, and by doing that, I'll easily know if I can fit these books. But so, for example, this was an easier example. But let's say if I had something bigger, for example, something the size of a room, and if I at that moment wanted to know that could I fit all these books in that larger cupboard, for example, and it would be a very silly thing to always try and see how many books can I fit. Okay, so I wish there could be a way by which I could just measure some things and find out if I can fit all these books, or how many books can I fit inside that cupboard. So for that, what I need to know is the space occupied by all these books here that I have. Is that space less than the space that is inside this cupboard, or is the space occupied by these books more than the space that is inside the cupboard? So what is the technical word for space occupied by anything actually? So that is actually volume. So volume is the space occupied by any object. So for example, if I take this book here, so this occupies a lot of space, right? You can see clearly it occupies a lot of space. So it will take a lot of space inside the cupboard. So this has a very large volume. Whereas if I have this book, this is pretty thin, okay? Although it has a large area, larger than this book, but this is pretty thin. So this won't take as much space as this book below this one. So yeah, I hope you can get the intuitive idea of what volume is. Volume is not mass. Remember, mass is mass is how much matter this thing has inside it. Okay, so for example, and an indication of mass. So indication is something that how do you know how much mass something has? Is its weight or how heavy it is. So this thing is pretty heavy. For example, if I take this book, this is pretty heavy. So this has a high mass, whereas this is not as heavy. So this is low mass. But if I take let's say a bag of air, or a bag of air of the same size, so that would have the same volume because it would occupy the same space, but it won't be as heavy as this book, and so it would have lesser mass. So that's a small distinction between mass and volume. But here we are not discussing mass. Here we are discussing volume. So that is the first way in which you can think about volume, the space that is occupied by an object. So for example, the space that is occupied by this book is its volume, and the space occupied by all these books is the volume of all these books. So why do we need to use that use volume? The first reason could be to find if you could fit this inside this. So for that we need to know how much space it occupies or how much volume it has. Let's look at the second example. So for that I need to get rid of these books. So now I was trying to make a recipe of a cake. So for that recipe, I had to actually use a particular amount of milk. So the amount of milk that I have to add has to be perfect, okay? And let's say I want to communicate that recipe to my friend over a phone call. So how do I tell him how much milk should he take? So I'll just give you an example of that. Wait, I'll just get the milk here. So here I have the milk, and so this is the amount of milk that I need to put into the cake to make the perfect recipe. So how do I communicate this information to my friend over the phone? Well, one thing I could do is I could tell him the volume of milk that he needs to take. So what is the second use or interpretation of volume? Well, it could be the quantity of anything that I have. So obviously that is precise. Obviously the quantity of something is mass, but yeah, when I talk about a fluid generally, so the amount of fluid that I have generally at a constant density is given by its volume. So I could tell him that put in this much volume of milk and you'd get the perfect recipe. So that is another use of volume, or maybe that is another use of volume that I need to use. And if I drink this milk up, so I'll just add a bit of chocolate. And now if I just drink up this milk, so what I get is an empty cup. Now for example, if I wish to know how much milk or water this cup can hold, again I need to know the volume of this cup. Okay, the volume that I can hold in this cup. So that is the so that gives me an indication of how much fluid, maybe water or milk, can I hold in this cup. So the third interpretation, a third interpretation, or the way you can visualize volume as, is the capacity of a hollow object. So this is a hollow object, right? This is a glass, a hollow glass. So the capacity, or the so the capacity of this glass to hold any fluid is its volume. So that is the third simple way in which you can visualize volume. And yeah, that's it. So the three, just to recap, the three ways in which you can visualize volume is: firstly, the space that any object occupies, or maybe the second way in which you can visualize is how much um, the amount of that substance there is. So maybe you may have 2 liters of milk, 3 liters of milk, that way. And the third is the capacity of a hollow object, so even that is volume. So obviously the three might seem different, but the three are essentially volume. And that's just, and we just saw that right now.